In this experiment we're going to look at the electrolysis of lead bromide. So remember, electrolysis is the breakdown of a substance using electricity. This can happen with ionically bonded compounds, providing the ions are free to move. So at the moment I've got solid lead bromide in the crucible here. It's connected to a circuit and a 12 volt power supply. There's a bulb in the circuit, and as we can see at the moment the bulb isn't lit because the ions aren't able to move in our particular ionic compound, lead bromide. Ways in which we can free up the ions for giant ionic structures: we can melt them and make them molten, or we can dissolve them and form a solution. In this case, what I'm going to do is I'm just going to use a Bunsen burner to start to heat our sample, and as it melts the ions are then able to move. It will complete the circuit. We would expect the bulb to light and the compound will break down. In this case the compound breaks down to produce metallic lead and bromine. After about 5 minutes heating, we can see we've provided enough energy to break the strong electrostatic forces between the ions in lead bromide. The bulb in the circuit is now lit because the circuit is now complete. The ions are able to move. At the positive electrode, at the anode, if we look closely we can see some bubbles. That's bromine vapour that's being produced at the anode. And at the negative electrode, at the cathode, lead ions are attracted. Reduction is taking place and we're going from lead ions to forming metallic lead. At the positive electrode, oxidation is taking place where the bromide ions are losing electrons and forming bromine gas. That's the breakdown of lead bromide using electricity.